Hi guys, welcome back to the channel. In this channel, we have looked at multiple IPsec site-to-site VPN using different vendor equipments such as FortiGate, pfSense, MikroTik even. But we didn't touch on one of the bigger one, which is the Palo Alto Firewall. So in this one, we are going to see how you can set up IPsec site-to-site VPN between two sites using Palo Alto Firewall. So this is a step-by-step guide that I have on my website. I'll put the link in the description, you may check it out. It has all the step-by-step instruction on how to do it. So if you scroll down, you will get the table of contents, and these are the configuration that we're going to do, the same exact configuration we're going to do in this lab guide. Okay, so let me scroll up and I'll show you the topology. If you right click and open in a new tab, you can see the topology in much better. Let me open the row topology from the draw.io. In a high level view, if you look at the topology, I have a California site behind Palo Alto Firewall and the other one is in Bangalore. Hold on, but I can see another site as well, London. What about that? Well, I'll be creating the video for that as well with the hub and spoke topology where California site will act as a hub and Bangalore and London will act as a spoke. All these using IPsec VPN. That will be for part 2. But in this one, we'll focus on setting up VPN between California and Bangalore using Palo Alto Firewall. I have a plan to expand this into automation and SD-WAN and stuff, so stay tuned for that. So let's get started. As always, if you like what you're watching, please like and subscribe. That would encourage me to create more such content like this one. And if you got any suggestions, comments, you know what to do. You see, I can simply build an IPsec configuration from California site to Bangalore site without giving much details and confuse the audience. Instead, I want you to understand the topology first and then build network on top of it. That way, it will be easy for you to understand what's going on. So let's explore the topology first. Let me zoom in a bit. On the left, I have a California site with a subnet of 10.1.0.0/16. You can see a lot of subnets here, don't get confused yourself, but I have not configured all. I just configured Linux subnet in VLAN 10 across all the switches, and I got a Linux machine called Ansible Ubuntu host with an IP of 10.1.10.20 that I'll be using it for testing. And all the switches behind Palo Alto are on the network management subnet as well, which is on VLAN 100 with a subnet of 10.1.100.0/24. And I configured that as well. So speaking of subnet, the second octet represents site, for example, 1 for California and 2 for Bangalore and 3 for London and so on. And third one would be VLAN. So if I'm using VLAN 100, it will be 10.1.100 for California. So if you look at this, all these subnets, right, I'll not be configuring it manually now. Instead, I'll be using Ansible to configure those. So if you want to learn how to do that, wait for the upcoming videos. So ensure to subscribe for that. Also, while configuring IPsec, we will not be advertising these smaller chunks. Instead, I'll use the whole /16 to route. So it would be easy to configure the route through VPN. So in case if you want to do /24, you might as well try that, but we'll stick with /16. I'm trying to simulate actual production environment kind of a setup. If you look at California site, the whole inter-VLAN routing happens at the core switch. And from the core, I have a OSPF running towards the Palo Alto, which carry the whole routes from the core to the Palo Alto Firewall. In return, Palo Alto send back default route via OSPF to the core switch. Whereas in Bangalore or London, all the gateways are moved to the firewall. I've configured VLAN interfaces on that interface connected to the switch. So the link between the Palo Alto and the switch act as a trunk. Let me update that on the topology, trunk, and London as well, trunk. But in California, it's an access port. That's actually on 10.1.99.0/30. And let me add OSPF as well. OSPF, looking good. And switches, of course, pure L2. Okay, so there is nothing much. So we'll configure the IPsec tunnel at California site first, and then we'll move on to Bangalore site. Once done, from California Ansible Ubuntu host, I'll test the network connectivity to the Windows server, which is located in Bangalore. And later, once we are done with the California and Bangalore, we'll create another tunnel between California and London in a separate video, of course, because we don't have time for that now in this video, where California site will act as a hub. So if Bangalore wants to talk to London, it can go via California. So let me log into the firewall. As mentioned in the topology, California has these networks, and the public IP that you see with 1.1.1, it's not mine. That's a random public IP that I use for ease of understanding. And if you look at the virtual router routing table, click on that, you'll see all the routes in there as well. And if I switch to Bangalore firewall, all the gateways are created here as a VLAN subinterface. Before we creating an IPsec tunnel, the first thing that you need to do is to test the connectivity between the hosts so that we know what we are doing, right? Let me switch to the Ubuntu host in California. This is the California Ubuntu host and it has an IP address 10.1.10.20. In Bangalore, however, we have a Windows host and it is on a Windows VLAN, right? And if I check the IP config, you can see it has 10.2.10.50 IP. If I try to ping from Ubuntu host, it will fail. However, if I try to ping the internet, ping 8.8.8.8, it is working fine. So I can reach the internet just fine, but the communication between the site not working, which we are going to fix in this lab. Let me continue to ping the remote host so that we can test afterwards. Let me check out the situation in Bangalore as well. If I ping the internet IP, it is fine. However, if I ping the California site IP, it doesn't work. So let's fix that right now. So the first thing that we are going to do is, before creating the IPsec tunnel, we are going to create an address object. Although this step is not mandatory, you can still use a subnet manually each time, but I gotta tell you, it will save a lot of time during creation as well as troubleshooting. So let's go ahead and do that. Go to object, address. You can see I already have an object. Let me add a new one. Click on add. Let me name it BGL subnet 10.2.0.0 / cannot be used here in the name, so _16 in the IPnet mask 10.2.0.0 / 16. Click on OK. The California one was already there because I had to create a policy for the internet traffic, so I created that already. Let's now create an IPsec tunnel. The IPsec configuration mainly happens in the network tab. So click on the network tab. So there are two phases of IPsec configuration, phase 1 and phase 2. So first we'll create IKE crypto and then IKE gateway. That is part of the phase 1 configuration. Second, we'll create IPsec crypto and the tunnel interface is a part of phase 2. Third, we'll combine all the above and create IPsec tunnel. And finally, we update the routes and policies. That's it. Very simple, right? So let's see. Let's go ahead and create an IKE crypto. Click on it. These are the default ones. I don't need any of these, although you can use the default ones to create the tunnel. But let me delete this. Delete, yes. Let me also delete the IPsec crypto as well. Nothing in IKE gateway, great. Back to IKE crypto. Click on add. Let me create a name that I'll use it throughout the tunnel creation. So I can name it like CAL, that is short for California, HQ to BGL. Let me copy this one so I could use this again and again when I have to mention the name. IKE crypto. For the parameters, you can choose whichever you want as long as it matches on both sides. So in DH group, choose group 14, encryption AES 256 CBC. You can choose other one as well. Authentication, choose SHA-256. That's it. Click on OK. Next, configure the IKE gateway. Click on IKE gateway and click on add. Paste the name that we copied earlier and IKE gateway. In the version, choose IKE v2 only mode. In the interface, choose the WAN interface. In my case, it is Ethernet 1/1. Local IP address, choose from the drop down. Peer IP address, you have to get it from the remote side. This is the one. Open it, copy that, come back to California site and paste it. In case if you are using Dyn DNS or something, you could use FQDN as an option and update the Dyn DNS FQDN here. For example, safe.paloalto or bgl_cal.dyndns.com if you are using Dyn DNS or something similar. We are not using Dyn DNS, so it's fine. So for us, it's just an IP. So choose that, enter pre-shared key. Just use some strong pre-shared key here with some complex characters. Confirm the pre-shared key, just paste the pre-shared key again. Don't worry too much about local identifications and the peer identification. It should work just fine without it. When using NAT configuration, however, if the peer won't come up, you can try these settings. You may now click on advanced option. If your firewall is behind NAT device such as an ISP router, or you don't have a public IP directly configured on your router, you can check this option, enable NAT traversal, provided any IPsec traffic destined to the firewall is doing one-to-one NAT between the public IP on the NAT device and the private IP you have on the firewall. In my case, I don't have that issue, so let me uncheck that. In the IKE crypto profile, choose the crypto profile that we created in our last step. And one more thing I want to tell you, Don't check this enable passive mode option. The California site will not initiate the IPsec connection. Instead, it will act as a responder. Only when somebody from the remote initiate the connection, I'll respond to the tunnel. So it will act as a responder, not the initiator. I'm not going to check this, so uncheck this as well. But if you have that requirement, you don't want the tunnel to be built when the traffic is initiated from the California side, then you can check this option. You might as well play around with that. Click on OK. The phase 1 is complete. Now let's go ahead and create phase 2. Click on IPsec crypto, click on add, paste the name, IPsec crypto, encryption is AES 256 CBC, authentication SHA-256. DH group would be group 14, that's it. Click on OK. On to creating the tunnel interface. Click on interface and click on tunnel. I don't have anything at the moment. Click on add. In the tunnel name, add the number whatever you like between 1 to 9999. I'm adding 1. Here choose the router. If you have not renamed the virtual router, it would be showed as default. The only zone I have is for the LAN network, which is inside, and the WAN network, which is outside. So I don't have a zone for the IPsec, so click on new zone. To create a zone for IPsec, and name it like maybe IPsec itself, and click on OK. It has chosen the zone that we just defined, and I don't need any IPv4 unless I'm planning to do any kind of dynamic routing such as OSPF or BGP, so I'm not going to do that. Sometimes the users may complain that the application is not working and you see the traffic is going, so you are not getting any response, some sort of issues. So you might want to adjust the MTU for the IPsec tunnel, which you can do it in advanced settings. Or while building an IPsec tunnel towards a cloud provider such as Azure or AWS, you cannot go with the default MTU size. So they would ask you to reduce to 1400 or 1440 or 1424, something around that range. So I am leaving the default one in the advanced. All looks good and click on OK. The tunnel one is now created. We basically completed most of the steps. Let me also add a comment here so that it is easy for us to identify what this tunnel is all about. Paste the name we copied earlier and tunnel and OK. We will now create an IPsec tunnel with all the parameters this and this that we defined so far. Click on add, paste the name, IPsec, choose the tunnel interface that we defined, tunnel 1, alright. Choose IKE gateway as well and IPsec crypto. I'm not doing anything in advanced options, although if you have multiple ISPs with multiple tunnels, you could do a tunnel monitor from here and do a failover based on the tunnel monitor IP availability, thus providing redundancy. I'm not doing any of that now. That's fine. Don't need any proxy IDs between the Palo Altos. Paste the name, click on OK. You can see the tunnel is now showing down. The tunnel info is a phase 2 of the tunnel. As you can see, there is nothing in here, and the IK info is a phase 1. So it's also showing down in red color. We have now completed the IPsec tunnel configuration, but there is still a problem that we have to fix. Anytime when the California site users wants to talk to Bangalore users, by default it will take the internet path because it will take the default route to go out to the internet, and there is no specific route for the Bangalore site to divert the traffic. Let's go ahead and add the routes. Click on virtual routers and open the virtual router cal vr1. You could do either dynamic routing or static, but in this lab we'll do just static routing. In fact, I have a step-by-step guide here on how you can configure BGP on top of IPsec tunnel. So if you are interested, you may check it out. I'll also put the link in the description as well. So click on static routes, click on add, BGL route, destination is 10.2.0.0/16. In the interface, it's going to be tunnel 1. You don't need to put anything in the next hop. Instead, I will change it to none. And you also have the path monitoring option as well. If you have multiple tunnel, you could use this option. I'm not doing any of that now. Click on OK and click on OK. Now the route is defined. However, the traffic will be blocked by the firewall by default. Kind of like a security gate. Only when the gate is open, you are allowed to go. So we need to define a policy to allow the traffic from LAN towards IPsec tunnel in Bangalore. Currently, I only have a single policy that allows the traffic to the internet. Let me add a new one. Click on add. Allow traffic from CAL to BGL host. In the source, click on add under source zone. Choose inside. In the source address, click on add and add the object that we defined earlier. If you have a user ID agent configured, you could define the user here, but I don't have it configured, so I can leave it blank. Click on destination tab We will be talking to Bangalore and the tunnel is in IPsec zone. So choose IPsec, destination address. Remember we created address object for Bangalore as well. Click on add, choose a Bangalore address object. Since this is a lab, I'm allowing everything. But in production, you must restrict to whatever the resources that the user is trying to access. That's the whole point of having a firewall, right? Not everything. For example, HTTP or HTTPS that you can see here. So I'm allowing everything, so it's fine, it's a lab. With these changes, I'll be able to communicate from California to Bangalore and click on OK. Let me commit the changes. While it's committing, let's go back to Bangalore and do the same thing. First, let's create an object like we did in California. Click on object. I already have an object for Bangalore site, which I created for the internet policy. Let me add a new one for California. Let me clone the same thing. Clone, okay. Click on that and rename to Cal HQ and then subnet to 1 as well and click on OK. To create an IPsec tunnel, go to network, under network profile, IKE crypto, delete this and same in IPsec crypto as well, delete yes, IKE crypto and click on add. Whatever you do, ensure all the IPsec parameters match on both sides. Enter the name BGL to Cal HQ. Let me copy this one and IKE crypto. DH group 14, encryption AES 256 CBC, authentication SHA 256, click on OK, click on IKE gateway, click on add, paste the name IKE gateway, version IKE v2 only mode, interface, choose the WAN, which is Ethernet 1/1, choose the local IP from the drop down, get the peer IP from the remote, go to network, interfaces, Ethernet 1/1, IPv4, copy the IP, come back here and paste it here. Paste the same pre-shared key that you used in California site. So let me paste that, confirm the pre-shared key, paste it again, click on advanced options, choose IKE crypto we defined, BGL to Cal HQ IKE crypto. That's it. Click on OK, click on IPsec crypto, click on add, paste the name IPsec crypto, encryption AES 256 CBC, authentication SHA 256, DH group 14 and click on OK. Next, create the tunnel interface. Click on interfaces, tunnel, add, name is 1, paste the name under comment to identify the tunnel easily, BGL to Cal HQ tunnel, choose the virtual router, choose the zone, so I don't have any, so let me click on create new, IPsec, OK. It is now selected IPsec as zone and click on OK. Go to IPsec tunnels and click on add. Paste the name, IPsec, tunnel interface tunnel 1, choose IKE gateway, choose IPsec crypto profile and click on OK. It's showing down at the moment. Let me commit the changes I have done so far. Commit. We have completed the IPsec part. Now let's add the routes like we did in previous one. Click on virtual routers, open BGL VR1, static routes. I only have a default route. Click on add, Cal HQ route, choose the destination as California object, interface tunnel 1, next hop none and click on OK and OK. Now to the policies, click on policy tab, security and add allow BGL to Cal HQ host. Source gonna be inside, source address gonna be BGL object, destination zone is IPsec, destination address California address object, action allow and click on OK. So what we have done so far, we have created the tunnel between two sites and created a policy from California to the Bangalore location and Bangalore to California location as well. However, there is a problem. When the traffic is initiated from the California site, it will indeed send to the California HQ firewall IPsec because we already have a route and policies in place at California site. But as soon as the traffic leave from California and arrive at the Bangalore site, it will be blocked because we have not defined a policy at Bangalore to allow traffic from IPsec to Bangalore LAN. So technically, we have created an outbound policy in California. However, we have to create an inbound policy in Bangalore. Back to policy configuration in Bangalore firewall. Oh, I forgot to mention traffic. Let me add that. It's not needed though. I like it to be perfect. So, okay. Click on add. Allow traffic from Cal HQ to BGL. Source is IPsec this time. Source subnet is California object. Destination zone is inside. Destination subnet VGL object. All looks good and click on OK. Finally, commit the changes. Now any traffic from California to Bangalore will be allowed. But same is true for the other side as well. Any traffic initiated from the Bangalore LAN side to California will be sent to the IPsec tunnel by the Bangalore firewall, but when the traffic arrives at the California Palo Alto firewall, it will be blocked. So we will not create a policy for now. We will test the traffic now from California to Bangalore. Once that is done, we'll test the traffic from the other way around as well. From Bangalore to California, when things doesn't go well, we'll fix the issue by creating the policy in California. The commit is now complete. This is IPsec tunnel status in Bangalore. It is down. Let me check in California. It is showing down as well. Let me go to Ubuntu host at California site, login. These are the initial traffic which is packet filtered. It should work fine now. Let me stop it and try again. I'm not getting any response. That's weird. What did I miss? But interestingly, the tunnel has come up. So this is a good troubleshooting scenario we got. If I look at the monitor traffic, I see the traffic is passing as well, and it is allowed in California with the policy that we defined. Everything is matching. If I come back to Bangalore, refresh the tunnel, and the tunnel is up here as well. The monitor traffic. Oh, the traffic is reaching Bangalore side as well. That's weird. I must have done something wrong. Let me try to ping the gateway. It is the Windows gateway in Bangalore 10.2.30.1 and it works. But why is the Windows server not responding? That's weird. Let me also go to Firewall CLI in Bangalore and try to ping from there as well. Show interface all. We have Linux, Windows, network management and public interfaces. So if you ping by default, it takes the management as a source. So I have to define the source that I'm going to initiate the ping from. So ping source 10.2.30.1. Host is going to be 10.2.30.50. Still not working. What's going on? Let me check the Windows firewall. Maybe that's blocking. Windows Defender firewall. Can I turn it off completely? Turn Windows Defender firewall on or off everything. And okay. Oh, that's still weird. It's not working. Let me check the IP again. What? I have a Linux IP 10.2.10.50, not Windows 1, 10.2.30 range. Oh man, that's why it was not working. So let me revert the firewall change on the Windows machine. I suppose to have this IP 10.2.30.50 in the Windows range. Let me go back to the firewall CLI and change the IP to 10.2.10.50. Oh, that worked. And on the Ubuntu host, oops, not again, 10.2.10.50 and it is working perfect. It was a minor mistake which I didn't notice. Maybe you must have noticed it during while I was checking the IP, but I can tell you this can happen in real life production networks too if you're not careful. So watch out your IP addresses, alright? So right now I know what I did wrong because I must have kept it in the wrong VLAN. So let's go ahead and fix the Windows machine, put them in the right VLAN. Let me log into the virtual switch that I have and check the interfaces that connected to the Windows server. Show IP interface brief, exclude down. It's connected to 2, show run interface gig 0/2. No, this is a trunk. Not this either. This is a 1 gig 10. Show run interface gig 10. This is the one interface gig 10. Switch port access VLAN 30. Let me remove the encapsulation which I added when I was testing the link as trunk. No switch port trunk. Oops. Encapsulation. Show run interface gig 1/0. Save that. I still have the old IP. Let me disable the interface and enable it back. ncpa.cpl, right click and disable and enable. If you connected to the Windows machine using the RDP with the same IP, don't try to disable the interface like this. It will kick you out. So always do this when you have a console access to the VM, which I have. Alright, IP config again. There you go. We got an IP address from Windows range 10.2.30.50, which we are trying to ping before. Let me switch to Ubuntu. It is stuck. Stop it and initiate the ping again with the Windows IP, and it is now working fine. What if I ping the other way around from Bangalore to California? Will it work? As I've explained, it will not. Let's find out. Back to Windows host, ping 10.1.10.20 -t and it is not working. Let me keep this aside because we have created policy on the Bangalore LAN to California, but not California IPsec to California LAN. Switch to California and configure the policy. Policy, click on add, allow traffic from BGL to CalHQ. Click on source. Source zone would be IPsec. Source address would be Bangalore address object. Destination zone is going to be inside. Destination address is going to be California address object. Action should be allow and click on OK. Commit the changes. It is still committing. Let me keep the Windows screen here. It is still timing out. Let me fast forward this. Okay, 98% done. There you go. It is now working fine. That's it. So we have now enabled bidirectional communication between these two sites using IPsec tunnel. Great. I hope you liked the video and got some value from it. And next we'll add some complexity and configure IPsec towards London and California like an hub and spoke topology. Thanks for watching, and I'll see you guys on the next one.